In this tutorial, we're going to configure InterVLAN routing using the router on a stick method. Now, the best thing about the router on the stick method is you can have as many VLANs as you need going through the same router. Whereas if you were using the legacy method for InterVLAN routing, you would have to have a router interface for every VLAN that's connected to it. So this is the better way. Okay, using the configuration handout that I provided for you in Blackboard, you're going to have a router, you're going to have a switch, and you're going to have two PCs. So let's put these devices up in our workspace. Okay, let's go ahead and configure our PCs with a subnet mask and default gateway. Okay, there's the first PC with the IP address of 172.17.10.10 and the default gateway of 172.17.10.1. The other PC, the IP address on it is 172.17.30.10 with a subnet mask of 255.255.255.0 and a default gateway of 172.17.30.1. Okay, let's go ahead and connect our media. We're going to have copper straight through cables all the way here. So from PC 1, from the Ethernet port up to the switch, up to port F01, PC 2, we'll go from our fast Ethernet up to F11, and then from the switch F21 up to our F00 port on our router. Okay, now we're ready to start creating VLANs on our switch. And we're going to have two different VLANs. We're going to have VLAN 10 and we're going to have VLAN 30. You'll have PC 0 here connected to VLAN 10. You'll have PC 1 connected to VLAN 30. So in the configuration here, we'll click on our switch and we'll go to our command line interface and we'll begin configuration. So enable config terminal, config T, VLAN 10, VLAN 30. Then we'll do int F01 switch port mode access and switch port access at VLAN 10. And what that's doing is that's assigning F01 to VLAN 10. Okay, moving on to F11. So int F1/1 switch port mode access, switch port access VLAN 30. And that assigns the port 11 to VLAN 30. Okay, let's exit out and exit out. And let's do show VLAN brief. And you can see where these assignments have been made. Okay, VLAN 10 is assigned to F01 VLAN 30 is assigned to F11. Okay, next, let's configure our router using the sub-interface method. So on the router, go to the command line. Do I want to continue with initial configuration dialog? No, I do not. Okay, so enable config T. Okay, int. On the router, we did F0/0.10. Now the .10, that indicates that it's a sub-interface. Encapsulation type is going to be .1Q for VLAN 10. And the IP address that will be given to this is 172.17.10.1. What we have put as the default gateway for PC 0. And then, of course, the subnet mask. Okay, moving on for the next sub interface, int F0/0.30, and this is where we're configuring the sub interface for VLAN 30. Encapsulation type again is .1Q, and the VLAN number is 30. IP address 172.17.30.1, which is the default gateway that we assigned on PC 1, and then of course the subnet mask. And let's exit out here and we'll show IP interface brief. And you can see where these assignments have been made. Okay, F00.10, the IP address has been assigned, and F00.30, the IP address has been assigned there too. Okay, the next thing we need to do is we need to go back to our switch. And on our switch, go back to configuration mode, and we need to configure the trunk port. In order for both VLANs to communicate with this router, the connection between the switch and the router has to be defined as a trunk port or a trunk link on the switch. So int F2/1 switch port mode trunk. And let's exit and exit again and show VLANs. And you can see the assignments have been made there. Okay, we have VLAN 10, we have VLAN 30, and so forth. Now, let's go back to the router and let's issue the no shut command for F00. And we can see that the interface has changed to up for both VLAN 10 and for VLAN 30. Now, if we have configured everything properly, even though PC 0 and PC 1 are on separate VLANs, they should be able to communicate with each other because they're going through the router. Now, if we just had the switch and no router, they would not be able to communicate with each other. So, from PC 0, let's ping 172.17.30.10. And we see that this was slow. The reason it was slow is because it's building the routing table there, and it's building the switching table as well. So, that ping was successful. Let's go to the other PC, and let's verify communication there as well. And we are successful there as well.